Hello all, my name is Chad Palwal and welcome to this series of Code First Machine Learning. In this series of videos, we are going to see how we can implement machine learning algorithms from scratch. As a reference, we are going to use the DASMIC machine learning library, which is available in GitHub, and a link is provided in the description of this video. This will be a series of videos. We are going to start from a high level, like a 30,000 feet view, go down to the surface slowly. But first, we'll take a look at the design of the machine learning library and how each of the algorithms are implemented. Now, the DASMIC machine learning library has been implemented in C Sharp, which is a programming language originally developed by Microsoft, but now it's open source. Now, C Sharp is very similar to Java. So, you know, when I started work on the DASMIC library, I had a decision to make, and I decided to go with C Sharp because it has more compatibility with other languages, plus it has very inherent support for parallelism that can be leveraged. And the solution for DASMIC is built on the .NET Core, which means it can work across multiple OSs. And there's always a argument to choose which language is the best, so don't want to go deeper in that. But the main idea behind this is to show how object-oriented principles are applied in building machine learning algorithms and how the concepts of reusability, inheritance, and other OOP concepts can be leveraged. So when you download the DASMIC machine learning library, it has a solution file, and when you double click on the solution file, this is what the solution looks like in Visual Studio. Now, if you don't have Visual Studio installed, I will encourage you to have that deployed in your machine. You can do other language development in Visual Studio also. This is Visual Studio 2019. Microsoft provides a free version which is called the Community Edition, and Visual Studio has a really nice IDE. In fact, along with JetBrains, I will rate Visual Studio as one of the top IDEs for development. So when you open the solution, you're going to see three main folders: application, code base, and unit test. Most of the algorithms are built in the code base, and then for most algorithms, we also write unit test. An application is something that consumes any library that the code base provides. So let's take a look at the application. Now each folder has multiple projects. Now in the application side, we have some basic features about licensing support and a simple app console application, and also a simple Excel add-in. Now most of these are still like work in progress, and most of the work in the library is in the code base as well as in the unit test, which is basically testing every algorithm that is provided in the code base by providing it like fixed kind of data. So let's expand the code base and also the unit test. So as you can see, the code base and the unit test have very similar structure. They have algorithms. There's a common folder and a math folder. Same in unit test. There's a common, oops, I moved this folder here. I can move it back. So we have algorithms, common, and math. Now let's expand with the math. Each of these folders as an application contains multiple projects. So on the math, we have a project to support matrix computations and another project to support statistics computation. There will be a corresponding unit test project for each one of these libraries under the unit test folder. So under unit test, there's a math, and as you can see, the namespace in unit tests start with unit tests, as well as the namespace in the code base start with DASMIC. So starting with the namespace unit test means this is a specific unit test for the corresponding project inside code base. Let's look inside common. So there will be a common area in the unit test. Now, as you can see here, there's not a one-on-one correspondence because some of the common areas deal with some basic libraries which are actually used elsewhere. So we haven't written a specific unit test for that. So we do provide a unit test for the ML core and some file operations, which is actually part of the IO module. Now the IO module primarily deals with input output, like reading files and writing files. So it's kind of portable, but you have to write one for every specific OS. So right now we have implemented one for Windows. And similarly for data management. Let me just minimize the common folder here and expand the algorithms. Algorithms is where the projects for each of the common classification as well as regression problems in machine learning are defined. So as you can see, there's a project for each common type of algorithm, starting from Bayesian to decision trees to deep learning to neural network to regression to support vector machines. And if you expand the unit test side, there will be a corresponding unit test project for each one of these algorithms. Now, each one of these libraries exist as the independent DLL. So this makes the whole design very modular. That say, for example, you want to use only a decision tree in a project, then you only need the decision tree algorithm or the DLL along with the common DLLs that provide the IO and the common functionality, and of course the math DLLs too. Now the math DLL are basically the foundation of this whole project, because essentially machine learning is nothing but extended statistics, and they use a lot of common mathematical functions too, and a lot of matrix manipulation functions. So these are provided again the matrix and statistics libraries. Now, if we go and open the project of these algorithms, so let me just show you how that is done. You can simply right click, or let's go into a specific project here. So if I right click on the decision tree and say open file in File Explorer, it opens up my folder tree. And if I go into the algorithm, I can see that there is a folder, which is a project folder for each one of those projects. So let's go inside the decision tree. If we go into the bin folder, there will be a DLL for the decision tree. And it automatically copies other DLLs that are required, like the math.dll and the ML core.dll, which provides the core functionality, and we'll dive into them later. Now, if you expand each one of these projects, let's take an example of the decision tree. In the core algorithm project, there will be a build and a model and a support function. Now, this is common across each algorithm. So let me expand the Bayesian, and for example, let's take a look at the neural network project. There's a build, there's a model, there's a support. Now, what these are doing is the model is the data structure which contains the definition of the model that we are building. Now, if you serialize the model, you actually get a ready-made model that you can consume by deserializing it. Build is where most of the algorithm work goes on. So build is the basically contains the code that incorporates the algorithm, and it returns a model. So essentially what you are doing is taking data, passing it to the build, and then getting a model in return, and then you can serialize the model and persist it into a file like a JSON file or any binary serialized file, and then you can use that model elsewhere with your own data to train your model. Well, yeah, to train your model, and then use the once the model has been trained, then you can use the results for prediction or classification or whatever your use case will be. So this is a very common format across all the algorithms. What we have done is try to build a consistent framework across each one of the machine learning algorithms. And remember, each one of the machine learning algorithms are very unique in nature, like some are doing regression, some are doing classification. But once you have this common structure, it builds up a design pattern how you want to increase the capabilities of the library. So this is a very high level overview, and then in the next video we are going to dive a little bit down, say at a 20,000 feet level, and take a look inside the basic structure of a build model and how the corresponding unit tests are designed. Till then, I'll see you in the next video, and if you have any feedback, please leave a comment below. Thank you for watching.